All right, this is Chapter 3, Lesson 3.1, dealing with inequalities and their graphs. So in this lesson, we are going to be writing, graphing, and identifying solutions of inequalities. Okay, so writing an inequality. How do we write an inequality? Well, I want to start by doing two examples where we're giving in words representation, and we're going to change that into a mathematical inequality. So in part A, it says all real numbers x less than or equal to -7. So all real numbers x is the first portion. And how we represent that is we just write x. It's a variable. And then the next portion is less than or equal to. So remember, less than faces away from the variable. And then equal to, we're just going to put a bar on the bottom. And then -7, we just copy over. So it should read like that. And we're going to do another example. So 6 less than the number k is greater than 13. Now, see how it says 6 less than a number k? Even though this less than, normally we think of the less than sign, we're not going to think about that. We're going to think, remember, 6 less than a number k. So we're going to do k minus 6. Remember, less than. If there's a than, then it goes at the end, okay? So the 6 comes after the k. So k minus 6 is greater than 13. So this is what our inequality should look like. Okay. What is an inequality that is represented by the verbal expression? Okay, so all real numbers p greater than or equal to 1.5. So all real numbers p, that's our first portion. That's just going to be p greater than or equal to 1.5. And let's do b. The sum of t and 7. So remember, sum means add, so t plus 7 is less than -3. So less than -3. Okay? Is the number a solution of 2x plus 1 greater than -3? This is what we call by identifying solutions by evaluating. So what we do is we take this number, which is -3, and we have to test it in our inequality. So we're just going to plug it in for x. So in this case, this -3 gets substituted for x, and we're going to get 2 times -3 plus 1 is greater than -3. So 2 times -3 becomes -6, plus 1 is greater than -3. -6 plus 1 is -5, is greater than -3. Now we have to test if this makes sense. -5 is not greater than -3. So -3 is not a solution. And we're going to try the same thing with -1. So remember, we're just plugging it in. So it's going to be 2 times -1 plus 1 is greater than -3. 2 times -1 becomes -2. Plus 1 is greater than -3. This becomes -1 is greater than -3. This one works. -1 is greater than -3. So -1 is a solution. How do we graph inequalities? Okay, so for graphing inequalities, so n less than 1. So let's find 1. Now, whenever it is less than or greater than, but not equal to, it's going to be an open dot. So we're going to draw a circle instead of a dot, a closed dot, okay? And if it says n is less than 1, so can be anything less than 1. It could be 0, it could be -1, it could be -2. So we're just going to fill in the part of the number line that n could possibly be. Now, n could not be 2 because 2 is not less than 1, so we're not going to fill in that side. It's only going to represent the side that the variable could be, okay? A greater than or equal to 0. So let's find 0. Now, in this case, we are going to shade it in, so we're going to put a closed dot. Why? Because it's less than, or it's greater than or equal to, okay? And now A could be 1, A could be 2, A could be 3, A could be 4. It has to be greater than 0, so we're going to shade in this portion of the number line. Because remember, if A is greater than 0, A can be any number that's above 0. And in this case, that's to the right of 0 on the number line. All right, so F greater than -3. So let's find -3. And we're going to put, remember, an open circle because it's not equal to. And if F is greater than -3, it could be -2, it could be -1, it could be 0. So we're going to go and shade in this right-hand portion of the number line. All right. -2 is greater than or equal to x. Let's find -2. Put a closed dot on -2. Remember, x is going to be less than -2, so we have to fill in this side. If it helps for these kinds of problems, you can just switch the order and change this. So it can be x is less than or equal to -2. And one way you can check is see how the the sign was facing away, the mouth is opening towards the -2 versus the x. Okay, that means that when you switch it, it should also be facing away from x. So this is correct as well. Sometimes that helps just to have the variable on the left. I know a lot of people like to see it like that. All right. So what is the graph for each inequality? Let's go ahead and do these. So we're going to take A, x greater than -4. So let's find -4, put an open circle around it, and x must be greater than that. So x could be -3, x could be 7, anything that's greater than -4. So we're going to shade in this area to the right. Let's try C greater than 0 for B. So let's find 0. Remember, open circle because it's not equal to. And C must be less than 0, so we have to shade in this side. Because C could be -1, 2, 3, it could be -9, could be any of those, okay? And for part C, we've got 3 is less than or equal to n. So we could rewrite this as n greater than or equal to 3. So let's find 3. Let's put a closed dot on 3, because remember it's equal to. And n is going to be greater than that, so it has to be all of the region to the right. And remember, guys, you can always check if you did it the right way. Anything that's shaded, so let's say we see that 7's part of the shaded region. If we plugged in 7, does this make sense? And it does. 7 is greater than 3, so we're good to go. Okay, writing an inequality from a graph. All right, so for these, you could use any variable that you wanted. I'm going to go ahead and use x for both of them, but you can use whichever variable you would like. Okay, So I see that from -1 on, so we know that at -1, we have, that's where we're starting, and it's greater than -1. Let's put x over here, and I see that it's a closed dot, it's not open, so we're gonna put equal to. X is greater than or equal to -1. For B, x, I see that at 4, we're moving to the left on the number line. So all these values are less than it. So I'm going to put less than. And remember, it's not equal to because it's an open circle and the number 4. X is less than 4. All right, so check yourself before you wreck yourself. Answers are on the next page. I want you to try these on your own, and then we're going to go over them together. So what algebraic inequality represents all real numbers y that are greater than or equal to 12? Okay, all real numbers y, so that's going to, we're going to start with y, that are greater than or equal to 12. Y greater than or equal to 12. All right, is the number a solution of 6x minus 3 greater than or equal to 10? Well, all we have to do is plug in. So let's try A. So this is going to be 6 times -1 minus 3 is greater than or equal to 10. So for A, we get 6 times -1 is -6 minus 3 is greater than or equal to 10. So this becomes -9 is greater than or equal to 10. This is no. So A is not a solution. I'll just put no. Let's try B. Six times 0 minus 3 greater than or equal to 10. This becomes 0 minus 3 greater than or equal to 10. -3 is greater than or equal to 10. That one's also no, not true. Let's try C. C, we have 6 times 3 minus 3 is greater than or equal to 10. 6 times 3 is 18 minus 3 greater than or equal to 10. This becomes 15 greater than or equal to 10. This one is true. 15 is greater than 10. So this one is, yes, a solution. And let's try our last one, 4. So for D, we've got 6 times 4 minus 3 greater than or equal to 10. This is 24 minus 3 greater than or equal to 10. This becomes 21 is greater than or equal to 10, which is true. So this one is a yes. All right, for number 3. What is the graph of 2 is greater than P? So let's draw a nice little number line. Like this, 0, 1, 2, 3, -1, -2, -3. Okay, and we've got, what is the graph of 2 is greater than P? So P is going to be less than 2. Let's find 2. And that should be an open dot over 2. And then remember, P is going to be less than 2, or 2 is greater than P. So it has to be the shaded region, all of this to the left. And then for number 4, what inequality is, let's check our, okay. What inequality represents the graph? Well, let's start with X. And I see that it's less than or equal to, because it's a closed dot and it's moving to the left. And we've got -3 there. We can check our work. Got that one right. Nice. So we got no, no, yes, yes. And we've an open circle at 2 filled in to the left. And let's check number 4. Perfect. We're good to go. And now your exit ticket. So I want you to explain the difference between x greater than 0 and x greater than or equal to 0, and explain the difference between x greater than 0 and x less than 0. Good luck.